Physics Part 11. By scale drawing figure, scale 1 centimeter represents 2 kilometer per hour raised to power minus 1. The velocity relative to the shore is 6.3 into 2, 12.6 kilometer per hour minus 1 in a direction 18 degree east of north. B, by calculation referring to the diagram given in the figure and using Pythagoras theorem, R2 is equal to 12 square plus 4 square is equal to 160. R with the under square 160 gets the result is equal to 160 under square is equal to 12.6 tan theta A 4 over 12 is equal to 0.33 and tan theta A is equal to 18.4 degree. The velocity of the ship relative to the shore is 12.6 km per hour, power raised to minus 1 in direction of 18.4 degree. Now it's your turn. A swimmer who can swim in still water at a speed of 4 km per hour raised to power minus 1 is swimming in a river. The river flows at a speed of 3 km per hour raised to power minus 1. Calculate the speed of the swimmer relative to the river bank when she swims. A downstream and B upstream. Draw the scale to a vector triangle to determine the resultant of the two forces shown in the figure. Check your answer by calculating the resultant. The use of a vector triangle for finding the resultant of two vectors can be demonstrated by means of a simple laboratory experiment. The weight is attached to each of the flexible thread, and the thread is then suspended over two pulleys. As shown in the figure, the third weight is attached to point P near the center of the thread. The string moves over the pulleys and paper held on the board behind the thread. This is easy to do if the light from the small lamp is shown at the board. Having noted the sizes W1 and W2 of the weights on the ends of the thread, a vector triangle can then be drawn on the paper as shown in our figure. The resultant W1 and W2 is found to be equal in magnitude but opposite in direction to the weight W3. If this were not so, there would have been the resultant force at B, and the thread and the weights would move. The use of the vector triangle is justified. The three forces W1, W2 and W3 are in equilibrium. The condition for the vector diagram of these forces to represent the equilibrium situation is that three vectors should form a closed triangle. Since it's a closed triangle, it's an equilibrium. Figure shows apparatus to check the use of the vector triangle. The vector is a triangle, in fact. We have considered only addition of two vectors when three or more vectors need to be added. The same principles may apply provided vectors are coplanar or in the same plane. The vector triangle then becomes a vector polygon. The resultant forms the missing side to the closed polygon. We subtract two vectors, reverse the direction, that is, change the sign of the vector to be subtracted and added. The resolution of vectors. On page 11 to 14, we saw that two vectors may be added together to produce a single resultant. This resultant behaves in the same way as the two individual vectors.